Why does a capacitor block DC but pass AC? A capacitor is two parallel plates with no electrical connection between them. A wire is attached to each plate. The plates can have a very large area and a very small gap between them. They could be formed from two sheets of foil with a layer of paper between them and the whole thing rolled up to keep it compact. But it's still just two large plates with a gap between them. If you connect a battery to the two wires, a small amount of charge will flow for a short time. It will shove electrons onto one plate and pulls electrons from the other. Pretty soon, there is just a voltage difference between the two plates, equal to the battery voltage, and no more current is flowing. It has come to a standstill. That is the blocking DC part. Direct current cannot keep flowing because there is no path for it to bridge the gap between the plates. Now suppose we connect the battery for a few nanoseconds. During that short time, a few electrons get sucked off one plate and roughly the same number get shoved on the other plate. There is an electric field between the two plates due to having more electrons on one side than the other. But the voltage has not yet built up to the battery voltage because we only connected it for a very short period of time.
Now, quickly swap the battery terminals. Now we attract electrons back from where we pushed them before, and push other electrons to the other side where we took some away before. Let's do this for 2 nanoseconds. So now we have reversed the situation and we have the opposite electric field between the plates. But we only let the current flow for a very short time. Not enough to build up to the battery voltage. Keep repeating that, alternating the direction of the current, but doing it so fast that it never saturates. That is alternating current. The circuit acts as though current is flowing through the plates. It isn't actually flowing, but the circuit behaves as though the AC is flowing through the capacitor.